Objectives. Describe the steps involved in an effective troubleshooting methodology. We'd like to apply a standard methodology because we end up with consistent results that way. Hopefully consistently good, but consistent results. And the reality is when it comes to troubleshooting, once you become a good troubleshooter, you can really kind of start to troubleshoot almost anything. It doesn't just apply to computers, cars, and things around the house. The troubleshooting skills the methodologies are really very similar from one field to another. The specifics are obviously different, but the general techniques are pretty similar. Follow a systematic troubleshooting process to identify and resolve networking problems. Document symptoms, solutions, and results when troubleshooting network problems. Why? Because chances are you're not going to be with that organization forever. People that follow you, the people that work with you, they kind of want to know what you did to fix a particular problem, if it worked, things like that, so that in the future they can address that same problem more quickly and do a better job the next time that a similar problem crops up. And then use a variety of software and hardware tools to diagnose problems. So the last bit of the chapter talks about some of the various tools that are available. So troubleshooting methodology. To proceed logically in methodology, follow a set of recommended steps. Use experience when necessary. The idea is you want that established methodology to be able to follow it so you can produce those consistent results. Yet at the same time, do you have to follow that methodology every single time? Well, not if you've got experience that suggests you've seen this problem before. You might be able to skip a few of those steps, go right to the problem. If that fixes it, great. You save some time. If it doesn't fix it, then you need to go back to the beginning and start.
Thank you.
You're welcome. Start from the very beginning and follow that methodical approach. Logical approach benefits, prevents wasteful, time-consuming efforts, unnecessary software and hardware replacements, things like that. So the troubleshooting steps in general: identify the symptoms and problems, define the problem essentially first. That's what it's basically saying. Identify the affected area. How large the scope of a problem is it? Determine what's changed. If something has changed recently, there's a fairly good chance that that's contributing to the problem. It may not be the case, but it's oftentimes a good place to start. Establish most probable cause, it's usually the problem. Determine if the escalation is necessary. Are you capable of handling it, or does it need to be bumped up to somebody who has more expertise in that particular application or that particular piece of hardware? Create an action plan and a solution. Implement the solution and test it. Identify the results, did it work, and then document the solution for future support personnel. So identify the symptoms of the problems. How do you do that? Talk to the people. Ask them what's going on. Have them reproduce the problem for you. Have them show it to you. Pay attention to what those users are doing. Watch how they're doing things. For example, in some cases you'll have a shortcut on the desktop that you may go to when you have a problem described to you with respect to Microsoft Word. Maybe that's not how the user's actually opening Word. Maybe they're going to the Start menu, Start Programs, Word, and opening the program that way, and that's where the problem's occurring. So watch the user, see how they're doing it in order to start to identify the problem. Identify the affected area. Is it the individual's workstation? Is it larger in scope? Is it covering a group, an office, or a department? Is it an entire area within an organization, or is it the entire organization? It starts to clue you into the scope of the problem. Scope could also refer to the time frame. When did the problem begin? Is it something that's recent? Has it been this way for a long time and the user just never complained about it until now? Because now it's starting to affect something they need to do. So identify the time scope as well. Take time to troubleshoot correctly. Ask specific questions to identify the scope. Filter out unrelated user information. So the stories about their kids and playing on computers and how good they are is great and cute. That doesn't really help you to diagnose the problem itself. So a lot of times you're going to have to filter out what the user is saying. But at the same time, you need to listen to what they're saying as well. So it's kind of a balancing act of what's important versus what needs to be filtered. So the book does a pretty good job in a few places of providing you with a workflow diagram to kind of step you through the troubleshooting process. And you can kind of look through those. But Is the problem limited to one user workstation? You know, it's kind of building the scope, the geographic scope of this particular problem. It kind of fans out from there. So if the answer is yes, examine the individual workstation for problems with possible user error. Certainly a possibility. Is the problem limited to one department? If the answer is yes, examine the network segment, group, server group, router, and so on. Or is the problem universal? So again, it's just building the geographic scope of the problem, which gives you insight into where to start looking. This one, another flowchart, tries to identify the time scope of the issue that you're having. So when did the problem start to act up? Have the devices ever worked properly? Probably should be one of the very early questions that you ask, because in a lot of cases, it's a brand new product. It's got to be new. It just came out of the, or it's got to work fine. It just came out of the box. Defective products do get shipped. So, has the device ever worked properly? Is always a really good question to start with. Then try to figure out if something has changed recently. Maybe there was a patch that was recently updated. Maybe virus definitions were updated. Something of that nature. If something has changed recently, a lot of times that's the culprit, or at least start to point you in the right direction. So try to identify if anything's changed recently. As far as trying to handle recent changes, you really got two approaches you can handle that with. Correct the problem itself. In other words, the change occurred, now we've got to fix it. Or we can try to back out of it and reverse out. In some cases we can do that, in other cases we can't. So it really sort of depends on the situation as to which one's the best approach. Establish the most probable cause. Close to determining the problem cause, verify the user competency. Make sure that they know what the user actually knows what they're doing. Assuming that that's the case, verify that the user is performing the network task correctly. Stand over the shoulder and watch them. If you can't physically be there with them, see if you can remote desktop into their machine so you can watch. Other than that, you can talk them through it over the phone, in which case you want to talk to them have them slowly go through the various screens and describe what they're seeing. It tends to be a little bit more difficult, but in some cases you don't have a choice. And the goal of this is to try to identify any user-generated mistakes. In a lot of cases, that's going to be the case, but in other cases, you've got swift users in some cases that they know what they're doing, and by doing this, you're just verifying the user's not the error, and that it's actually a problem coming from somewhere else. So with all that in mind, you're trying to recreate that problem and learn more about the problem causes. See if you can reproduce the symptoms as the user. See if you can reproduce those symptoms as a privileged user, so as an administrator or something close to that account access. The idea is to try to determine whether or not it's a rights issue or not. Is it, somebody has a rights to a particular directory to add, delete, modify, etc. Try to follow the same steps, and again, continue to ask questions of the user to narrow down what the problems are. Verify physical layer connectivity. Half of all network problems occur at the physical layer. What is that? Somebody kicked a cable loose. Somebody cut through a cable. There's too much interference for wireless, things like that. So symptoms of physical layer problems: segment network lengths exceed standards. We went 120 meters instead of the 100 meters that we're limited to. So that can generate some errors. We've got noise. We've got improper terminations, damaged cables. We've got cables going across the floor, and somebody's chair rolls back and forth over it. So it was working fine, but over time we worn a hole in one of the cables and torn the cable. Faulty network interface cards. Software errors may point to physical connectivity problems. If you've got a cable that's starting to go bad, the shielding's starting to break free, a lot of times you're going to see what looks like a software error. It's going to be caused by that cable. Diagnosing physical layer problems: ask questions, verify connections between devices, verify soundness of connection hardware, and then we proceed to swapping equipment. In the PC world, that's what we do. We swap what we suspect as bad equipment or malfunctioning equipment with known good equipment. And the idea is to narrow down where the defective component is. So if we think we have a bad stick of RAM, we swap out RAM, trying to identify with a bad stick. Change patch cables, and best option, build in redundancy. If you got extra RAM, you may not even notice you got some defective RAM in place. So again, verifying physical connectivity and a nice little flow chart for that. Any questions so far? Only half the class here. Okay. Continuing, verify the logic. Review questions identifying logical connectivity. Logical connectivity problems more difficult to isolate. Why? Because there's just so many potential places where we might have a configuration problem that is generating an error of some kind. Software-based causes resource conflicts with NICs and how they're configured. We may have two IP addresses assigned on the same segment, so that could generate a problem. Improperly configured network interface card, improperly installed and configured client software. So there's a lot of different places where we as an administrator can make a mistake, or a user can make a mistake, or there can be some other type of problem that's generating a logical error on the network. And so that can be a little bit more difficult to track down in some cases. Determine whether escalation is necessary. How do we know that? Well, we have to have some kind of infrastructure in place in order to be able to escalate to somewhere, right? If everybody's at the same level, there is no escalation. So traditionally this is done through some type of help desk approach, in which case we'll have one or more levels of support. Typically, if we're a larger organization, we're going to have 2, 3, 4 levels. And our first level is really going to be designed to handle the vast majority of the problems, probably 80% plus. And that's the goal that you really want for first level support. To be able to address the issues that the vast majority of users are having. So resetting passwords, helping them to clear their print queue so they can get a document printed. Basic tasks like that. They tend to have, first level help desk personnel tend to have a broad base of knowledge, but not particularly deep. And that's because they're dealing with a lot of different users, dealing with a lot of different applications. Second level support tends to be a little bit more depth with respect to their knowledge. Maybe their breadth of knowledge isn't quite as great, but the depth within the areas that they are familiar with is more. So when you have a specific user with a specific type of problem, you might direct them to second level support. And then for the particularly pesky problems, third level support higher are really designed for very specific applications, very specific pieces of hardware that typically have very complex setups. And as a result, they require a high degree of specialization. How do you escalate? What's the process for going through that? That's dependent on the organization. Every organization is going to have their own procedure for moving a problem up to a higher level of support. For example, you may have an organization that requires all their, that supports other companies, and one particular company requires all their calls to go to second level support at the very beginning. Why? They feel like they have a priority or they need a priority. They're going to pay a premium for that access, but that's a choice that they have to make as an organization. So the procedure for escalation and how you move from one level to the next depends on the organization and what their needs are. Create an action plan and solution including potential effects. Consider how the solution affects users and network functionality. What's one of the first things you do? You turn it off, you turn it back on, right? You go to the router, you reboot the router, you unplug it for 10 seconds. Really good steps. That's great. Unless your boss is in the middle of a really big download. So you want to think about what you're doing and how that's going to affect everybody else. Is the solution that you're applying only going to affect you? Then fine, turn it off, turn it back on. If it's going to affect other users, you have to think it through a little bit further. If it's going to affect other users and this is an important fix, maybe you go around and you notify everybody, say, hey, shut everything down, we're going to reboot the router, and see if we can get it back up and working the way it's supposed to. If it's not something that's pressing, if it's something that can wait, maybe you wait till after hours. Maybe you wait till a time when the network traffic isn't as great, and it's probably a little safer to be able to do that. So there's a trade-off between what your approach as to how fast you want that device back up and running properly versus the needs of the existing users that are still continuing to function. You also have to consider security, be aware of inadvertent security implications. In a lot of cases, especially when a problem relates to rights, help desk personnel have a tendency to simply allow all. Let's put this person, let's let everybody print to every printer. And it's a way to quickly test to make sure that it is a rights issue or it's not a rights issue. Well, as long as you remember to flip it back to the way it's supposed to be, that's fine. But if you forget, now everybody continues to have the rights to print everything to everywhere across the organization. So you have to be aware of those security implications. You don't want people in New York printing stuff to a printer off in Los Angeles. It's not going to do them any good. All they're going to do is waste bandwidth and paper. Identify the scalability and the cost of solutions. Scalability, position the network for future additions. If you come up with a solution that's going to limit your ability to grow in the future, and you happen to be in an environment that is rapidly growing, you may need to realize that this is a very temporary fix, and continue to work on the problem even after you have a temporary solution in place. You may not have a choice in the short run, but in the long run, you still need to work on the problem. And then cost. Weigh the options carefully. Consider poor network performance identification. Address those areas separately. In other words, if the problem that you're experiencing is not catastrophic, you may want to simply deal with it because the cost of correcting it may be too great. So keep that in mind as well. Any other questions so far? Okay. So where do you get information about trying to fix various problems? They can come from everywhere. Google is a great source, obviously. But so is the manufacturer. I mean, the manufacturer makes the product. Who's going to know more about it than them? Microsoft, Intel, a lot of companies have their own knowledge bases that you can go to and access various error messages and various search terms that you can type in for various products. And you get a lot of information back from those organizations. They also produce a lot of white papers, webinars, etc., that you can listen to, you can watch, you can read, and you can learn a lot about their products and a lot about the various configuration options simply by looking through a lot of that. You can always pay for technical support. I tend to be cheap, so I don't read or watch a webinar, but that's just me. Implement and test the solution. So after you've tried, implement only after proposed solutions effects have been researched. So you've identified, okay, the boss isn't downloading some 8 gig file, so you can reboot it, the router. So let's go ahead and try it out. So implementation, is it going to be brief or long? How much foresight it's going to require? How much patience? Be patient. Think about doing a firmware upgrade to your router. Don't get impatient and unplug it in the middle of the firmware update. You might end up creating a bigger headache than you really wanted. Use a methodical and logical approach leads to efficient correction processes and less major problem fix as quickly as possible. Follow these steps and blah, blah, blah. So if it's a large problem that's affecting the entire organization, we were talking about scope earlier, if it's a large problem, we might want to roll it out to certain departments, certain users, certain groups, rather than doing it to the entire organization all at one time. After the solution implementation, verify that the problem is solved properly. So you go back to the user that was experiencing the problem, the users that were reporting a problem. Have them sit down and show you that, yes, the problem is fixed, it's working the way it's supposed to now, or no, it's continuing to have a problem, so we have to go back to square one. After testing the solution implementation, determine how and why the solution was successful. So in other words, you don't want to be shotgunning your solution. You're not just trying to throw solutions at the problem. You want to know specifically what fixed it so you know exactly what it was that was generating the problem. So hopefully you can avoid that in the future. So that as you continue to roll out machines, you've already applied that particular patch to avoid that problem. Determine the solution's effect on users and functionality. Avoid creating unintended negative consequences and communicate solutions to colleagues. You don't want to have to reinvent the wheel. If you find a solution and you don't share it with your colleagues, the next day, the following day, somebody else is going to run into it. Eventually enough time is going to go by, you're going to forget the solution, and you're going to have to reinvent the wheel again as well. So document always. Always record problems, symptoms, and causes, and the solution. Justifications for recording: it's impossible to remember each incident's circumstances. Again, the further away you get from the event, the more details are going to become hazy. Your job functions are going to change. So you need to record all that information as quickly as you can, preferably in some kind of centrally located database where various users within the organization, particularly help desk personnel, can access. If it's a small organization, it may simply be a spreadsheet, but you really need to have some place to document all this stuff. A lot of times it's going to be documented in some type of help desk software. One I'm familiar with is called Remedy. It's very customizable. You can add all types of fields to it. And the advantage to it is it allows a network administrator or a group of network administrators to compare notes and say, we have all these various different types of PCs, hardware, printers, softwares, etc. All that's documented in the help desk software. And now, as your personnel document various problems that you're having throughout an organization, you can identify the various pieces of software that are causing the most problems, the various users that are causing the most problems, the various pieces of hardware that are causing the most problems. And you can make future purchase selections, future training sessions, etc., decisions based on that information. So it gives network administrators an awful lot of information to go on. Notify others of changes, record the resolution in the call tracking system, communicate your knowledge, what you found out, what you discovered with your peers. And there's a cutoff about the degree that you really need to report. In other words, if it's a bonehead mistake, they kick the plug from the keyboard loose of the computer, you probably don't really have to record that. But it depends on the organization. At Help Desk College of Business in North Texas, they would have you report everything. If you leave your desk to go help somebody, you record it. So it depends on the organization as to the level of detail that you report. How to prevent future problems: network maintenance, documentation, security, and upgrades. The idea is to be proactive about it, to plan it ahead of time, to think about it ahead of time. Prevention is much easier than correction after the fact. That's what they're talking about there. So troubleshooting tools. What are some of the tools that you can use to make your life simpler for an existing network? A problem crops up. What can you do to try to identify where the problems are and start to fix it? Well, the obvious software one is ping. It's something that everybody jumps to very quickly. Most people are familiar with it. It's a basic connectivity test from one device, from one node to another. So it makes it very easy to say, okay, yes, packets are getting through, or no, packets are not getting through. But there's a lot of specialized tools that are out there as well that can give you a lot of additional information other than just some of the basic stuff that ping gives you. So they're specifically designed to analyze, isolate network problems. They range from simple continuity testers to protocol analyzers. And they have a variety of different, though similar, but different applications. Tool selection depends on things like the problem being investigated, characteristics of the network. So crossover cable is really probably one of the simplest. Something that would be very easy to test connectivity between two different devices without any need for any type of a connectivity device. So you don't need a hub, you don't need a switch or anything like that. And all it's really doing is reversing the transmitting and receiving signal wire pairs on the cable. Tone generator and tone locator. If you happen to come into a situation where the wires have not been well documented, they're not well labeled in the wiring closet, you can use a tone generator and a tone locator to be able to identify a pair of wires in a wiring closet to somewhere out in a punch down somewhere. So they give you an example here. You might have a tone generator on one end that you can hook up to the wires, and then over here on the punch down block, you can test to identify the wire, which particular wire that happens to be. So it allows you to, after the fact, start to identify specific wires. Now, the downside to this approach, you want to make sure that none of these are connected up to live hosts, or connectivity device. It's sending a signal through that wire, and you can potentially damage the router, switch, or network interface card. So you want to be careful, make sure you're not working on live wires with that. A multimeter is a multifunction meter. It provides you usually with a variety of different functions. You can test connectivity, you can test impedance, voltage, etc. So it performs a number of different functions. It's good in that sense, but it's not really quite what I'd call a specialized piece of equipment as it relates to what we would typically be talking about. So you can measure resistance, impedance, etc. So one might look like that. There are obviously simpler ones, more complicated ones. The continuity tester is sometimes referred to as continuity tester, cable tester, sometimes as an idiot box. All it's really doing is giving you feedback that a wire is making connectivity from point A to point B. So it doesn't tell you about the voltage of a wire like a multimeter might be able to give you. All it's telling you is that there's a physical connection between point A and point B. It doesn't tell you anything about the quality of that particular connection. One thing that it can tell you that's kind of nice is it can verify the type of pairing of your wires. So for example, if we happen to have a particular wiring standard that we're adhering to, it can verify that, say for example, on one end we have, on our cables we're using RJ45 ends. It can verify that our pinout is correct on both ends. So that's one nice thing about continuity testers, but again, it doesn't do anything with respect to telling us the quality of that connection. It's just telling us that there is or is not a connection. That's where cable performance testers come in. They're kind of like a continuity tester on steroids. They can do additional tests that can assess the quality of the cable throughout. So if all of a sudden we end up with part of the cable that has a lot more impedance, that might tell us if there's a crimp in the wire or something like that. So it can start to give us information about the quality of the wire. It can also give us information about if there's a break in the wire, that approximately how far down that wire is that break. That gives us a lot of information. If we need to start tearing holes in a wall, do we need to rip out the entire wall, or do we need to rip it out 5 feet away from the wall plug? It gives us that kind of information. And a lot of these devices work on fiber optic as well, obviously. Instead of sending the voltage down, they'll send light signals down. Voltage event recorders are kind of like multimeters measuring voltage. The difference is rather than measuring voltage at a specific point in time, it does it over a period of time. So it allows us to get a more comprehensive view of the power events that might be occurring in our particular environment. So if we periodically are losing power, or our power is dropping down to a certain level at a certain time of day, by recording it over time, we can identify that. And that's the purpose behind a voltage event recorder. Good question. And the reason these are important, especially if you tend to have an intermittent problem, especially that might be related to power, this is really kind of the approach that you want to take. It's not uncommon to have intermittent problems. That's probably the most common type of problem that you might face. If it's this type of an issue, a lot of cases it's related to things like, say, in the evening, that the security lights might come on. Might be related to the air conditioning compressor coming on, going off, etc. So by having it documented when these various events are occurring, you might be able to mesh that up with the events that are occurring in your network, if you're having intermittent problems in your network, and identify a relationship between the two events. And then there's a bus set, which comes more from the telecommunications industry. It's basically a fancy telephone, rugged fancy telephone that allows them to tap into lines and do a variety of tests on telecommunications lines. And then more from the software side of things, we have a few different tools that we can use to analyze various protocols. So network monitors, not to be confused with network analyzers here in just a second, basically allow us to do certain tests of some of the protocols that are being used. So network monitors interpret layers up to about layer 3, determine the protocols passed by each frame, but they can't interpret the frame data. Microsoft Network Monitor is an example. There's free versions out there, so it's not like you have to pay for it or anything like that. And a network monitor is going to allow you to identify certain types of problems that you might have. So if you're having collisions that are popping up, if you're having runs which are basically incomplete frames, they're not up to the minimum. Giant frames that are too large, larger than the Ethernet maximum. If you have a network interface card that's just blabbering away, that maybe a network interface card is starting to go bad. Negative frame sequence checks, so frames that have failed their CRC check. And then frames that are perhaps being generated just because of random noise on the network. So network monitors can allow you to identify those types of problems that are cropping up on your network. Protocol analyzers are really more what people tend to think of when they think about monitoring a network. That's what's going to allow you to analyze stuff all the way up to layer 7. So now you can actually see the content that's going into the application layer. So if somebody's sending a password in an email, you can read it using a protocol analyzer. Wireshark is an example. Some people call it a network analyzer. Basically the same features as a network monitor, but just a few extra features. Like I said, it can go all the way up to layer 7. And some people will refer to it as a packet sniffer or a sniffer. And it really goes back to a company that really started producing the product for early on. We referred to it as sniffer, and it just kind of took on that meaning for all the other manufacturers that make the same types of products. So kind of an example screenshot of the traffic analyzer, or protocol analyzer. Protocol analyzer offers versatility in information type and depth to collect more information that can be reasonably processed. Why? Because you're collecting data from all 7 layers, potentially from all the various computers on a particular segment. That's a lot of data. It gets very confusing to sift through. As a result, you typically want to focus on a particular problem where you might be suspicious if there's an issue. So you can set a variety of different filters in order to try to narrow that down. Before using a network monitor or protocol analyzer, learn what network traffic normally looks like. In other words, if you want to identify that there's a problem by looking at all this data, you really need to have a baseline first. You have to have something to compare your current traffic against during a normal period of time, because if you don't, you have no way of knowing is this normal activity or abnormal activity. And then the last tester that they talk about are wireless network testers, tools containing wireless NICs running wireless protocols. You can just walk around with a laptop, and there's a lot of software tools that you can use to be able to do the same functionalities. But a lot of times it's more convenient to have a smaller device that's specifically designed to test wireless networks. And that's the idea behind a wireless network tester. Let's see. Programs scan for wireless signals, discover access points, wireless stations transmitting, and in some cases, like I said, they're free. The advantages of commercial tools: portability, installed with wireless network analysis tools, and oftentimes they're going to have a more powerful antenna than you're just going to have built into your LAN. So unless you're walking around with a USB wireless NIC plugged into your laptop, chances are the wireless antenna on your specialized devices is going to be a little bit more powerful. So there's an example of Fluke, which is in terms of manufacturer of test equipment, they are a big player in that market. So this chapter, we talked a lot about the methodology of troubleshooting, and like I said, good troubleshooting skills really go from one field to another. I used to work with a guy who fixed TVs, and he learned from a guy that fixed TVs before him. And he said when he was learning about it, I always told him, to start out with the CVI, which is nothing more than a close visual inspection. So you open up the case, the vast majority of the time there's going to be a black spot or a brown spot somewhere on the board. That's probably where the problem is, or somewhere around there. So take a little bit of time to just stop and look closely at the problem. A lot of times the problem will kind of jump out at you, but you have to look for it. Then the chapter really focused on troubleshooting tools, tone generator, tone locators, multimeters, etc., etc. So I think it's a fairly interesting chapter.